All right, the last lesson of the year deals with graphing functions. So this kind of brings everything that we've learned in algebra together into one spot. So a function is what we're going to be dealing with, and a function is a rule that relates two variables. In this case, it's going to be x and y. So basically what a function is, it just says that any value of x has only one corresponding value of y. Okay, so what does that actually mean? Well, you are going to be given an equation that looks something like this. Let's say y equals 8 plus x. So seeing it like this, you can see that any given value of x, it'll have a very specific value of y. And how can we figure this out? Well, we can use a function table, or what you otherwise know it as is a table of values. So if I were to create a table of values or a function table, I can figure out different values of x and y. So in this case, let's just say x is equal to 1, 2, 3, 4. You can find out what y is equal to by doing the substitution. So in the first case, if x is equal to 1, y would be equal to 8 plus 1, which is 9. If x is 2, it would be 2 plus 8, which equals 10, or 3 plus 8, which equals 11, and 4 plus 8, which equals 12. So that's how you fill out a function table. Now, what are you supposed to do with these? Well, what you can do now is you can assume that these are ordered pairs. And this makes sense because you have an x value and a y value. So the corresponding ordered pair for this would be 1 for the x, 9 for the y, 2 for the x, 10 for the y, 3 for the x, 11 for the y, 4 for the x, and 12 for the y. And then the third step for functions, of course, would be actually graphing them. So in this case, we can graph it on a Cartesian plane, or we can make a graph ourselves. So for this, because I already have my Cartesian plane, I can draw it out right away. So let's look at that. We know with both positive and positive values, we're going to be working in quadrant 1. So let's plot these. So 1 is the x, I go horizontal, and then 9. We have 2, we have 10, 3, 11, 4, 12. So you can see that this is a graph of our function. Now, when we're dealing with functions, we are also looking to see if they are linear. In this case, they will be linear because we're giving you linear functions, and that means that they follow a straight line. So let's do a couple more function examples. So I'll erase this, and then I'll give you another function to look at. So remember, first step is creating a function table or a table of values, and then looking at them as ordered pairs. So if I give you a function that looks like this, say 2x plus 4, the first thing that we can do is we can make a function table. In this case, just to see it a little bit differently, I'm going to have my x values and I'm going to add them in there in randomness. So I'm going to have 2, I'm going to have 5, 6. Okay, this is still a function table. We just have to be careful with what we're substituting. So in this case, with my specific y value, when I have x is equal to 2, I'll do my substitution right here. So 2 times 2 plus 4. So I have 4 plus 4 is 8. Now what happens when it's 5? 2 times 5, right? I'm substituting it in for the x value. Plus 4 is 10 plus 4 is 14. If I have 6, 2 times 6 plus 4, so that's 12 plus 4 is 16. So you can see again that I have a very specific y value when given a value of x. And now the next step is, let's look at these as ordered pairs. So we can write them down. So this would be 2 as my x value, 8 as my y. then I have 5 and 14, and then I have 6 and 16. Now again, of course, we have these all positive values. So again, it is in the first quadrant. So we can look at this again and we can graph it. So let's graph it. So we have 2 and 8. I have 5, and I go up all the way to 14. And then I have 6, and I go all the way up to 16. So again, you can see, even though I have a gap, I didn't find the 3 and 4 values. You can still see that it can be connected as a line. So that's a linear function. In later grades, you will see things that are not linear. You'll see things, circles, ellipses, which is like an oval, and different shapes. Okay, so now let's look at one that goes into different quadrants. So let's have y is equal to 2x minus 7. Okay, so this will go into different quadrants depending on where we make our value. Of course, these functions go on forever. So if I kept going, it would go into other quadrants. But I'll show you in the table this time how it can go into other quadrants. So we'll make our function table, and my x value and my y value. So this time I'm going to do the same thing, 1, 2, 3, 4, and find out what my y value is. So if I substitute 1 into the function, so 2 times 1 minus 7. So I have 2 minus 7. So remember from our integer rules that I'm going to go left down the line, and I'm going to end up with -5. Then I'm going to find my next one, 2 times 2, subtract 7. So I have 2 times 2 is 4, subtract 7. I have -3. 2 times 3, subtract 7. I have -1. And then 2 times 4, subtract 7. And then I have 1. Now you can see from the other patterning work that we do, you can see how it relates. I told you before that the pattern, so this is going up by 2, is always beside the variable. So you can see how this relates to that. Now that we have this function table figured out, we can write down our ordered pairs, so 1 and -5, for us to plot them on a graph. 2 and -3, 3 and -1, and 4 and 1. And now we can replot on our graph. So before I do that, I'll have to erase our old graph, and I'll get plotting. You'll see that these are now starting in a different quadrant. So in this case, we still have positive x's, but we have negative y's. So that puts us in quadrant 4. So if I have 1 and -5, I have 2 and -3, I have 3 and -1, and then I have 4 and 1, and you can see it's already going back into quadrant number 1. And again, I can connect them to show that this is a linear function. Okay, I'll do one more example just to make sure that it's really clear. And we'll try and get into some other quadrants. So let's say we have y is equal to x minus 3. And let's get ourselves into different quadrants. So let's say we have our x and y values, and now we can try different things. So we can have x is equal to -3, -2, -1, and 0. So let's just try something totally different. And let's figure out our quadrants and our y values. So if I use substitution, the first one would be -3 in for my x, -3. I know with my subtracting that that is -6. Then I have -2 and -3, so it's -5. -1 subtract 3, -4, and then I have 0 subtract 3, which is -3. So now we have some different quadrants again. I'll always write my ordered pairs with my x value and my y value just so I know exactly what to plot on my graph. My 0, -3. And then I'll get out my graph to do that graphing. So let's see what quadrants we're in this time. So you can see that I have a negative x value and a negative y value. So that puts us into quadrant 3. So let's plot them. -3 and -6, -2, -5, -1, -4, and then -3 and 0. So remember that these lines are 0. So you can see that I'm in quadrant 3 and I'm approaching quadrant 4, and eventually we'll go in there. Now the last part that I just want to talk about is this very special point right here. So that point right in the middle of the graph, that is the 0, 0 point, and that is called the origin. And basically we call it the origin because that's where we're going to start, that's where we're going to originate all of our counting when we're doing our ordered pairs and our graphing. So that's an important vocabulary thing to note for the rest of your math learning, because this is an important point in all of the graphing that we're going to be doing from here.